Hi, I'm Alister Atkin from Atkin Guitars in the UK. Handmade acoustic guitars and electric guitars. This is our YouTube channel. Thanks for watching. If you like it, can you subscribe, tell your friends, click the likey buttons. Helps us make more of these videos. We're doing quite a lot of technical stuff over the next few weeks, which quite a lot of people seem to enjoy. We'll be revealing some of our top secrets, which I don't think many companies do. I think we're quite bold doing that. Anyway, this is Danny Martin.
Hello.
We've worked together for
18, nearly 19 years.
19.
Yeah.
It does seem a day too long. Anyway, do you want to give me a little tickle?
Sure. Yeah, all
right. So we're going to talk about a project that has kind of been, when did this start? About a year ago, wasn't it? Or...
Yeah, I think I started to try and get to grips with the whole CAD and 3D printing, CNC machines. It's always been something that I've been quite keen on the idea. I think for me, when the laser CAD, the laser machine first arrived, and then I sort of started playing around with it, and then that's just opened my world to new possibilities. So
what would happen really was that Danny was he's worked on every part of the guitar making process, and he was sort of overseeing a group of people, and we got to the point, we've already got one full-time sort of CAD drawer who does a lot of the technical drawings for the CNC machine and any other part that we want to make, whether it's a tool or a guitar part. And so I was thinking, we really need a second person. And when I mentioned this, Danny was like, could I be that person?
Yeah, definitely, yeah. When you first got the CNC machine, and then Ian used to come in, and I thought, I've missed my chance to do it. But he came with some experience, so I thought, okay, fair enough, But over time, I sort of, I quite fancy a go, And it's been a learning curve, like most things, but it's been very interesting. It's a modern tool.
Yeah.
And I've sort of very much enjoyed the process so far.
And what I recognised about Danny was that even when he was making the bodies, he'd be working with the laser cutter, and he'd be saying things like, I've worked out how to do this, and he'd come up with fixtures that worked in conjunction with certain parts of the guitar, so using them as like sacrificial sort of
little tabs that would hold onto like a little plastic clip that would locate the braces. Yeah, exactly.
And so you'd innovate all the time and get these little systems working.
It gets addictive.
Because we're always... What all of this technology does is it allows us to get repetition and sort of make the same product really well. And I stipulate this time and time again. We never move over to a new system until we think we're doing it as well or better than the previous system.
That's certainly my guiding force, is that, no compromise. And so the innovations that we're employing now frees up a human to do the things that humans do best, which is the finishing, the sort of and taking the time and attention to sort of just really, tidy it up. Whereas the grunt work of sort of whereas in the past we would have been shoving sort of wood through the bandsaw, and then onto the belt sander and just getting a face full of sawdust and what have you. That's not really where, especially with the numbers increasing now, is that's not where people.
No.
So
there's a whole sort of health and safety side to that.
Yeah, absolutely.
And then there's a sort of the toll it takes on your body when you're doing repetitious sort of hard graft over a period of years. So we wanted to try and get to the point where we took some of those. I mean, dust is a major consideration in the world that we work in. So trying
just having flashback to when I first started working here, and there's just like... no, nothing. No, none of that.
But no, but it's true. When you start a business, 30 years ago, extractors weren't really a thing,
They're a luxury.
Yeah, a luxury, yeah. And you'd sort of go into a workshop and there'd just be a guy, he wouldn't even wear a mask, be smoking and spraying guitars, or cars, or whatever it may be. And it's something that we've become very hot on, that we want to try and make the environment a nicer environment for everyone. Anyway, so a lot of those considerations have been the inspiration to try to move the whole process forward. But in that sort of process, we've discovered that there's been some major sort of push throughs with technology. Like, who would have thought everyone could have a laser?
Someone the other day about sort of 3D vacuum presses, creating for the jigs to hold the wood. If you've gone back, I don't know, 10 years time, what does any of those words mean? You know,
and like a 3D printer, anyone could have one in their house now.
Yeah.
And I'm sure lots of people do use them for little, you know, making a new light switch, or a bit of their kitchen broke off and they'll just design, you know, so it's become an incredibly accessible tool. And I think once we get these tools, we suddenly see, you know, someone suddenly their jaw drops, goes, hang on a minute, we could do this.
Yeah, it gives birth to a whole new sort of, you know, your brain starts going, how can I innovate using this?
And so one of the big things that we've been trying to do, holding work on a CNC machine or on anything is often the hardest part. And you'll hear sort of, whether it's a guitar company or anyone who uses a CNC machine, they'll say something like, if we can hold it, we can do the job.
Yeah.
And so one way that we used to use was that you'd sort of bolt something down.
Lots of
fixtures,
sort of heavy metal clamps and sort of kind of, I mean, some amazing sort of innovations in clamping. I was going to say that's chiefly...
proper engineer needs to do it though, you know, and that's costly. One thing that a CNC...
Well, and if it doesn't work as well,
exactly.
You've got to go back and
prototyping is expensive. And a CNC machine, no matter how well you program it, it will always have this weird Friday afternoon moment where it just plows through everything.
Many.
It's just like, oh, why did it do that?
Why did it do that?
So we thought, well, wouldn't it be cool if we could do this all in-house?
Mm-hmm.
And so Matt, who does a lot of the drawing, he started sort of working on...
Yeah, he's been the pioneer on the way, and then obviously been my mentor throughout this as well, you know. So
yeah, and so once we realised that we could 3D print vacuum jigs for holding down different parts of the guitar, it changed everything, didn't it?
Yeah, absolutely. Yeah.
And before, when you made a vacuum jig, you know, you might have made it on the CNC machine with expensive materials, and you'd have to make jigs to hold those jigs while you know. So it's kind of this chicken and egg situation.
Yeah.
Whereas a 3D printer, once you learn how to use it, it very much kind of just evolves in front of you. When you're printing, it just starts on a flat surface, and it's just sort of it
just builds up. Yeah,
builds up.
Sort of, if you was to do one of those time lapse, right, just sort of kind of grow.
And
over 24 hours or whatever. Yeah.
So we've now gotten to this point where we're looking at what the vacuum jig can do, what vacuum jigs can do, what the CNC can do, and trying to combine the whole lot.
Because at the moment, I've just noticed we've got this handy bit of wood here, so they were sort of kind of designing something that will hold that down for the CNC to sort of kind of come above it and, sort of do its magic, do the cutting. Primarily the first process is that it will put a radius on each side of this, this piece of wood is ready to go on the machine.
So for anyone who isn't getting this is a sound hole brace on the top of a guitar, and this will be two sound hole braces. There'll be one this side and one on the bottom side, and then it'll be cut in half. So this allowed us to then put this on a vacuum bed, and then it would route the radiuses. So there's a different radius on the top and the back, and that's a job that we would have done with a laser machine.
Well, I mean, going back
sander.
before that, we'd have a little sort of shaped piece of MDF and pencil mark it, put it through the bandsaw,
and then
sand it, and then shape it, and all the rest of it. And then we got the laser cutter, and you put it on there, and then it would sort of laser it out. Some of the pieces of wood it can laser all the way through. Some of it just put an etch in, and then you're back to the bandsaw, sander, etc. But with the CNC, obviously now is that it can have a sort of kind of a cutter that will sort of go, the full depth, and then just kind of keep going backwards and forwards, and end up with a nice radius on it. Yeah. So it's just as we sort of established, was the repeatable process thing.
And so I think what we're going to try and do in this video is show you this evolution, and then take you into the workshop and show you some of the tools that we've made. It all starts with a drawing, doesn't it?
Yeah. So this is sort of taking a while to get my head around, but we've got there. So this is a sort of 3D model of what the CNC bed will eventually look like. At present, we've got these 4 at the back that are the back braces, and I think I've got 2 of these so far. But eventually we'll have the X brace system that will go on there. This one here is actually, I mean, right from the very beginning, because this bed was being used for other processes.
I've had to sort of start bridges.
When everything came off. I had to sort of try and figure out, we better make a vacuum press for the rosettes. So the tops currently sit on top of there, and it does the rosette. So that's where I had to start, and then sort of build this up around it. Most of these haven't actually been 3D printed yet, but we've got enough of an idea to know that it's a success, and that it's gonna.
So that's the other side of it. It's all sort of prototyping all the time. So you'll come up with a system. Danny will then go, right, I think I'm ready to 3D print this. And a 3D print might take 24 hours or 2 days. And then this thing is ready to go. It goes on the machine. You put the wood on it, and then it's like, oh, it doesn't work.
That could have been better.
Do
I print it again? I don't know. If you take a look at this one, for example, this black piece here, this is the jig that the backs, you can see, are sort of kind of a back in situ there. That actually took 7 days to print that thing. Everyone was really impatient with me because I'd been using the machine for such a long time. But if that had worked out to not be very effective, then you've got 7 days. Oh no, I've got to start again.
And I will stipulate that one of the big problems with 3D printing that we've found is that 3D printing is temperamental. And we've bought a machine that was probably, I don't know, it's as big as a washing machine, and it cost maybe £6,000 or £7,000. Now you can buy a lot more expensive ones than that, but what we're a little bit unsure of, and anyone who might have done this, is how reliable can 3D printers actually be, because it
very hit and miss. There's a sort of 50%. If it's not.
After the weekend, you come in and go, oh look, somehow it's
made
gone.
Of spaghetti.
So that side of it is a bit of a wind up, but when it works, it's a beautiful thing. So this whole evolution so the whole project started with us trying to mechanise how to make a guitar body in its individual parts using CNC, vacuum clamping, 3D printing to hold the vacuum clamping, making these beds, and then the CNC routing out braces, making housing on backs and sides, on sides.
So where the braces go into the sides.
So it's all these different. It's a big sort of project to get your head round, and invariably when you start a project like this, you sort of think, oh, wouldn't that be good? And then you realise, oh, hang on a minute, if we do that, we've got to do that.
Yeah,
and then,
this is it. Yeah, go back and back.
And you literally
have to do that first.
You literally start at the beginning and go, and that becomes like a year or two's project. And with varying degrees of success along the way.
Yeah, because it's all, it doesn't exist yet.
No.
Until you, okay, I'll try that. And like you said.
So once you start seeing the benefits of this, it's a real buzz. And I think, having been in this business for, you 20 years, me 30 years, and seeing what other makers do. You know, if you watch we often go online and watch sort of tailor videos from. I mean, well, they were doing insane stuff 20 years ago that nobody else was doing, and we've never had the budget that perhaps some of those big companies or bigger companies have had. So everything we've done has had to be done on a sort of, I wouldn't say a shoestring, but on thinking about
efficiency.
Yeah, efficiency and like how much money we can actually afford to spend on a new machine or take a punt on a new machine.
Yeah.
You know, there was a time when thinking of spending £5,000 on a 3D printer would have sent, you know, it was just pipe dreams, you know. And
upgrade into the large belt sander at the time, and oh, you know, here we go, getting somewhere now.
So any hobbyists who are into all this stuff, or makers who are starting out, we've always believed that if we reinvest in what we're doing, things will, you know, get easier, quality will get better, all of those sorts of things. So it's 100% true that if you keep on those tips, but along the way you're going to spend a lot of money on things that you will never use and that end up in the bin basically, and sort of, you know, hopefully 80% of it does work, and that's what our experience is anyway. But I mean, should we go over and look at the system?
Yeah,
look
sure.
at the
Yeah,
workshop.
absolutely.
Is there anything more to add here?
Don't think so. No, the sides are over there anyway.
Yeah, we can sort of show you a bit more, and hopefully anything that you're thinking, I don't know what they're talking about, maybe it will.
Yeah, this is it. Yeah, you forget that.
This is our little world.
Yeah, exactly. Yeah, it's very easy to sort of get carried away.
Yeah.
Oh, look at this.
But I know there will be some other guitar makers who we all know that will be geeking out over this.
Yeah,
so it's kind of fun. But
interesting.
Okay, let's go over to the other side
Cool.
of the workshop. Yeah. Okay, so this is one of our CNC machines. This is the first one that we bought. Were you here when?
Yeah.
Yeah.
I think it was here maybe a year after I started.
Yeah. So that would be like in
2008.
2008, we'd bought this, and this is a shop bot machine. They come from America. It's quite a basic machine, but we've updated it. We've got a new spindle on it. It had a sort of old-fashioned router on it, which was really loud and horrible, wasn't it? But it doesn't have a tool changer, so you can hold one cutter at a time. So it's restricted in certain respects, but I mean, we've made, I don't know, 3,000 or 4,000 guitars on this as part of our production sort of machinery. So we decided to use this shopbot machine for this process because the stuff that was on this machine has now moved on to some newer machines with tool changers, which is better for sort of neck carving and fretboards, and so you've got all these different tools that you can use to make a better all of those production sort of systems better. So so this is a I think the bed is about 600 by 900 mil, so you can fit quite a lot on it. You could see in that video earlier on, this is the...
So that's the rosette that will hold the soundboard to have the rosette and the sound holes cut into it.
And if you look closely, you can see how a vacuum bed works. The air's coming in on this entrance here, and it's been sucked out through this hole.
This is the kind of air chamber, so to speak.
And you've got these two rubber gaskets so the air's being held in this area here, and it's a constant sucking down, so that when you put the work on there, you switch the vacuum press on, and it sucks it down, so it's on for the whole time that you're doing the work. Each one of these vacuum fixtures works in that way, with gaskets and sort of a locked bit of air in it to hold it down. So on something like this, it would need a little gasket that went round the sort of perimeter here, but if you break the seal, it will just fly off. So it's quite a sort of important thing to get right, and that's what most fails happen with when the seal breaks.
Yeah.
These are some of the things that we're doing. So there's sort of more bracing stock.
Yeah, that's for the smaller, for the 7mm, the 8mm, and the 12mm braces all go on these smaller ones.
Yeah, so that's some of that is for the top, some of that's for the back, and there's probably on most of our guitars there's 2 7 or 8mm braces on the back, and on the top the X braces are made with 7 or 8mm stock, and the transverse braces, the 2 braces under the bridge plate, they're also 7mm stock or 8mm, depending if it's a dreadnought, jumbo, or an O or something like that. So, I mean,
but this program now, because whereas in the past we would have thicknessed down from 8mm down to 7mm, the program that these run on will first of all go along and reduce it down to 7mm.
Yeah.
Obviously, if you want a 7mm brace, and then it'll complete the radius, and then it'll separate the two.
Yeah.
So it's doing a number of different processes within the same program. Yeah.
Absolutely. So now we've got this situation where we don't have to put this through a sander, so there isn't more sanding being kicked up as we thickness it, and then all these other processes, we've got extraction in this room, so we can shut this door and it's all happening in here, which is perfect. So yeah, let's have a look. Here's a good example of what
so that's the bracing stock, so to speak. So it's long, 2.5 meter long piece of sort of strip pine, and then this is the end result after it's been through the process on this particular machine.
So if you look at that, you can see that it's got these sort of sacrificial parts here which help the vacuum press to push these ends down once it's in
it's worth noting is that these are all universal. Every single one of the 20 this is a 20mm brace for the lower part of on the back. They're all going to be the same size, and then we're going to place it in situ, and then it's going to put the scallops on depending on which model we're cutting out, and cut it to length as well.
Exactly. So if you can make your life easier by making universal parts, certainly at the beginning, it means that if we're making something, we've got these sort of boxes of 15mm, 20mm, and it's all the same, and it's all going to work on the same with the same process. There's maybe one drawback, which is that you have to have the length for the longest or the widest back that you do. So, but we're talking about maybe a couple of inches that will become sort of
I mean, admittedly, you end up with sort of shorter pieces sometimes, and that will serve a smaller guitar. So it's not all completely. As long as you're careful when you're preparing it, is that you don't necessarily waste masses and masses of wood.
So also all of this bracing material has been baked in our oven, so it's been dried to get the moisture content really low, so that when we come to use it, it's in the sort of best state possible to retain the shapes that we're making. It's notoriously bendy once you sort of in certain situations. So to reduce the moisture on all of this stuff and know what moisture content you've got is brilliant. Should we have a look at the vacuum bed actually sucking some of this stuff down?
Okay, so these would be the the brace stock, so to speak. You want the grain sort of kind of running that way, because this is going to be cutting it on its side, putting the radius on. That's the first process.
That's quite nicely quartered there. So it will end up being glued to the back like that. So we're starting sort of on its side. So
they get put in situ there. I need to switch the. There we go. And then just, all the air channels are sort of isolated. You've got the switch there, and that'll pull it down, and you can see that's nice and.
Yeah, look at that. So to clamp like that.
Yeah, I mean, in the past, you would have had to sort of have, jaws, like metal jaws that would have sort of held onto it, trying to hold onto it tight, but then you've got the thing of, putting a mark on the piece of wood that you want as a finished thing, whereas this has no impact on your finished product or whatever you want to.
So it's just quick, isn't it, as well? So like when you were tightening stuff with either screwdrivers or Allen keys, and you might have something that went like that. But actually, I still maintain holding something like that. You know, you'd have had to have a clamp either side.
Yeah, and it has to be discreet as well, because you've got the spinning tool of the machine running, and you don't want it to hit anything that you're using to hold it on. So this is directly from underneath, presenting it up to the cutter.
Yeah. So you've got this thing's basically floating in air. It's pretty incredible.
Yeah.
So the other brilliant thing about vacuum is, you haven't got to undo anything. Or, there could be several sort of screws that you've got to take this piece out with. And if you were doing, well, like we are, 14 guitars a week, even just screwing stuff up like that takes, 2 minutes.
Yeah.
So then you've got like half an hour of just screwing stuff up. All you do with this is flick that little thing there and they just come off.
Yeah.
And then you want to put the next lot on.
Get the an example.
Get the next lot on.
So
straight back again.
Once that's run its program, then it's got this sort of radius on it.
You might see it down there, the radius. So that's what it's doing on that side.
Yeah.
It's coming in.
So this machine will just sort of kind of go up and down, and then end up with this nice radius that will, be our finished radius.
And there, if you get in closely, you can see what it's actually taking off. Now, one way of doing that would be with a table router, and we used to use a table router.
Yeah, with a whole
with
number
templates.
We've used a plane in the past. We've used, as I was sort of saying about earlier on, was the bandsaw.
Bandsaw,
you're marking your pencil mark on there, running it through the bandsaw, then running it through. But as is the way with it, sort of doing it over and over as well, is that sometimes if you sort of kind of slip or that
so
sort of thing,
you get just more waste in that way. So this is giving us a perfect situation each time. So once it's done that, we then go on to this.
Okay, so
fixture.
my next. I'll get a nice example of one. We've had a bit of teething problems with these, where the machine has sort of kind of,
mangled.
All part of the process. But so the next part of the process, once it's got that radius on, is that I've got this sort of piece that will sit on top of the jig. Did you want to?
So
it's got a matching radius.
It's got the same radius as this, and it just sits on like that. And what this has, I might go to this camera actually. Sorry. What this has, in order to help locate it, is this little wall here. So all you do is push it up against that wall, so it can't go anywhere. So you're instantly in the right place, which is perfect for this sort of job, isn't it? And then it just literally, go on, you put it on. Oh. It fits.
So it fits over the top. So the air that's coming, through this one now travels through this topper, as I've called it.
The topper, the Atkin topper.
Atkin topper, available at all good guitar outlets.
So that will sit on there.
There we go.
And that is a finished one.
Yes.
So, we're not getting there.
I don't think it does.
Let's put it. Right. So that shows you.
Yeah.
So that one jig can do both processes by just printing a slightly different jig to hold that, but we're using the same air system to suck it down.
So I was just going to get the cutter.
So to achieve this sort of round on here.
Yeah, we'll pop them on the topper, and then we've got a cutter.
Yeah, with a certain radius on it.
The shape, and then it'll travel up and down there, and then you end up with this kind of dome shape on the top there. That's kind of the finished profile. Yeah.
So, and that's all ready to go. And a job like that takes, how long does that take?
So the first process takes 24 minutes to do 4 of them, and then I think it's a similar sort of kind of amount of time, about 20 minutes to do that. But obviously that sort of seems like quite a long time. but it's the machine doing it in the background whilst you can be sort of kind of concentrating on finishing previous guitars. So.
Yeah. So with all of that, you're also if it's too short, or if it's really quick, that would be fine. If it's too short, you've got a guy standing here having to change stuff all the time, so he can go and do something else in that 24 minutes.
Yeah.
And because we don't make, we're not a mass production guitar company. We're just trying to make parts that are consistent and good quality. We've got plenty of time on our machines because we've got enough of them. That means that, we've got the capacity to run more if we need to. But it's just, this machine will last us ages before we got into a situation where we needed more output. So, it's fantastic.
You say that. I mean, this is the first one. Well, you got one next door there, a different CNC over there, so it's growing, and then about another three over
four over there.
Yeah, it is.
But the more that you have means that the capacity on that one machine it will work for us for ages. But it's important also for a company like ours. We don't want to be taking these jigs off this machine. They stay in situ the whole time, because taking some of this stuff on and off, getting location points perfect for us with these types of machines, because they're still light industrial, semi-hobby machines. There's stuff here that you don't want to sort of be moving everything. No,
because it needs to be in the same place every time. Yeah. That's where the computer sort of software, that's where it expects to find it.
Yeah.
So you don't. Yeah.
Yeah, and if it was like a millimetre or half a millimetre in the wrong way, it makes problems. Now, although I talk about these machines as being light industrial hobby machines, I've seen these shopbots in the Martin factory. So loads of people are using them. They're a very valid decision to use a shopbot, and then you can get into the bigger machines like the Haas machines, but something like this might be, say, $10,000, and the Haas might be $100,000. So it works for there's a tool for every job, really, and certainly for a company like ours, we have to be careful about where we sort of invest. So these have been fantastic. So this is an advert for ShopBot CNC. We've got how many? 5?
Yeah, never wear the complimentary cap that comes with it though, because that's when things go wrong.
Yeah, it always seems to go pear-shaped. Anyway, so we're going to take you on to the next phase of this sort of production system that we've been working on, and that's the sort of glued-on backs and the carving of the bracing.
Okay, so whilst the braces are being machined downstairs, we've got Martin, who has been at the mercy of my innovations and putting them into practice. And you'll start with, your journey, so to speak, starts with having cut the back out of the
African
piece of
mahogany here.
African mahogany.
Yeah, so it's a J43 standard we got. This is a new laser program with these little notches, little bits. So pretty standard, pretty much the same as before, but we're doing it kind of backwards this time. So we're putting the back strip on first, which is like more of a traditional type of technique, I guess.
Well, certainly where we started with the...
Yeah, I mean, for the past 2 years, I've been gluing the braces on first and then sort of putting the back strip in.
Yeah.
So now we're doing it like that. Stick it in the press. So this is an offcut of the Sitka spruce from the top itself. It's all going to be perfectly straight and in line, which is quite satisfying. I've had to cut it because it's not quite long enough.
So that's just a sort of generic strip that gets put into place there.
That's it, yeah.
And then it'll go down onto the machine and have the camber and the slots machined into it. That'll be the next stage after this part.
Yeah. Use my fingers to clean it up. And then we get it up to that line there. So the neck block is going to come to that point. Nice and centered.
Yeah, I mean the machining process will trim that up to length to accommodate the neck block anyway.
Have a little bit there, and just to check we're in line. It's pretty damn good. A couple of these little clamping cauls, and then.
How long does that stay in there for?
It can be a few minutes, to be honest, and then
okay.
the glue cleans off nice and easily. Yeah, you can leave it a bit longer if need be, and it goes a bit crustier.
Lovely.
Okay, so we've just come down from Martin. He's glued this back part on, and now we're ready to route the back strip.
The sort of make slots across for the braces that we've just machined to go in.
Yeah, so there's 4 braces here, and this will also be.
It's also going to put a sort of little camber. On that all the way down there.
So it's a perfect shape each time, which involves a little bit of sanding after this job, and then we'll put the braces on. But this back has been lasered out on the laser machine. It's got these location points, which mean that when we put this onto that jig, this centre line will be in the same place every time. And the way that this new vacuum jig that Danny's made works is that it fits every guitar back that we make. The longest guitar back is a D12 slot head, and the shortest is the parlour. So this jig here,
being the jumbo.
Yeah. So jumbo 17 inches wide. So this is the jig, and this is what enables us to put any size back we want on there. This location point is always the same, but this one can move around. So the vacuum jig has been printed on the 3D printer. It has a 15-foot radius on it, and this is the area here where the vacuum's working. And this is cool as well because Danny's put the Atkin logo in there. I always remember seeing, for example, Taylor always had their name on any piece of kit that they designed, and I always thought that was really cool. So it's a way of letting people know if they see these photos, they see that it's an Atkin product. I think that we might be the first people to do this on a CNC machine for backs in this way. Certainly with a printed vacuum bed. If you've seen it anywhere else, let us know, and we'll go and sort them out.
Kill them, yeah.
Well, I won't do that, but we'll. So the way it fits on is so sort of quick and natty. You just slide this to the point that you want it to be. You can see now that this back needs to be pushed down. At the moment it's flat, and if you switch it on, you just push it in position, and it holds the 15-foot radius perfectly. And the radius is, you have to think of the radius like this, as if you had a ball that was 15 foot across. This is the top of the ball, and it's cut out perfectly. So that's how our backs work. The tops have a 30-foot radius on them, and so when we come to do the top vacuum bed, that will have to be done completely differently, and there'll be a whole new set of problems for that.
Oh yeah.
For that. So then you've got a sound hole on that guitar as well. So the vacuum has to fit in a different area. There might be 2 little or 3 different vacuums.
There'd be something waiting that you couldn't possibly imagine is going to lay before you, but you'll find it.
So anyway, what this is going to do next, it's going to come in, it's going to route this back strip to give it a nice camber and a uniform camber. And once that's done, it's going to come across here and just route out the notches for the braces. Now, this is a job that you can do by hand. It's a relatively easy job, but it's also one of those things, if you're doing 14 of them in a row.
Again, one of those evolution sort of things, you know, going back to the beginning, you have to have the ruler across there, drawing it, pencil, scalpel, cutting it, all the rest of it. And then we got really clever and we got the hand router. We had that, do you remember the template system?
Notch template.
Yeah, okay, so that was, you know, again.
Yeah.
And then in the process of using a laser, I lasered sections and put the braces on first, and then laid the individual sections of the back strip in between those. Now we're back to the position where it's kind of more of a traditional way of doing it. In terms of our sort of history, is one continuous strip that is going to then have the slots kind of cut into it.
Exactly, and it's this system means that the way that those braces are made on the other machine gets a perfect 7 or 8 mil, or 20 mil.
And sort of kind of trying to keep tweaking it until it just
sort of slides into position, just beautifully seamless. So those are the sorts of repeatable processes that, if you work your system out, and you know, you could argue, well, that's not handmade. Well, what it is perfect, and we know we can hand make it if we want to, but we're now in this situation where if we can make this work for us, it's good for everyone.
Yeah, there's no compromise on that.
No.
It's because, you know, and now our time and attention can be done with the finesse. At the, you know, really tidying it up, giving a lot more attention to you know, that human touch. At the end of the process.
All those lovely little processes. I've heard it said many times before that a CNC machine is designed to take everything away, all the bits of wood away that aren't a guitar. and then what, you know, imagine you could have all these parts were made for you and you had to remove a millimetre of the stock. It's that millimetre that is the difference between a great guitar and a not very good guitar. So it's knowing the difference between those two things, really. CNC machines have been used so much to make mass-produced guitars, and what you notice is that there's, for some brands, there's compromise involved, and they'll accept a certain tolerance that actually does make that guitar look worse. And what we've always wanted to do was to find those tolerances so that we can continue making the guitars that we want to make, that look the way they should make and perform the way they have to. So, yeah, talk us through the next process.
Okay, so it's 2 programs. The first program being that it will run up and down here and put a very rough sort of kind of camber on there. Chop this end to length to accommodate the neck block, and then put slots in the position that relates to where the braces need to go.
So there you go, that's the back has been done, the back strip's sorted, it's got the slots for the braces. We're now going to take this up to Martin, he's going to glue in the braces, so yeah.
So this back has just come up from the CNC downstairs. It's had its notches cut into this. Also the back strip has had the sort of slight curve on the top, which previously was all done by hand, you know, like kind of sanding my fingernails off a little bit. So that's an advantage already.
Little strips of wood up on the...
Yeah, it's always fun.
Sander, not much.
So we go back into the dish, vacuum that down. These are some of the braces that came off earlier. So they've had a little bit of a hand sand just to take some of the tooling marks off. So I just dry fit it and make sure they're all the right length. Choose all the best looking bits of grain as well, just to go either side of the sound hole. Okay, so we've just done a dry fit just to make sure these all fit nicely. I've had to like adjust some of the little gaps just to make sure they're nice and snug in there. And then we get gluing up. So previously we had to use like clamping cauls and bits just to distribute the pressure, but with these higher bits, there's an advantage of, you know, not having to put any bits on, which is quite handy. So a little bit of glue, the whole surface area covered. Clean it up. Before I forget, these little locators, it was Danny's 3D printed, little Monopoly houses, right?
Monopoly hotels, I think.
Yeah, hotels, that's it, yeah. So they just slot in these little gaps.
So that's to locate the braces. They push up against that. And then the CNC will find it where it's expecting to find it.
And now...
Behaving.
Oh, yeah,
there we go.
it's not quite behaving.
Relax.
There we go. So it comes out of the vacuum press with a bit of glue all around it. It gets cleaned up and then it looks like this essentially. And then that goes back to Danny to go back on the CNC.
Take that downstairs, put it back on the CNC. It's going to have its scallop at each end of the brace and chop into the required length.
Okay, so we're down from the gluing station where Martin glued the braces on, and you can see here that they're beautifully fit into these linings. Yeah, it's really very, very good, and the way that these are now in line, so you get these perfectly horizontal braces. So the next stage is to put it back onto this jig, and we're going to carve the ends of the braces. We're also going to cut the end of the brace, which will allow it to fit into the housing of the curved lining on the sides perfectly. Now again, that job, it's not a difficult job necessarily, but it's a very
Repetitive.
It's repetitive
and time consuming.
Yeah.
For no discernible benefit.
No, exactly. So it's one of those things. If you can get it at this stage, it's really very good. So yeah, I think is that all we need to add to that. I mean,
I think so, yeah.
These braces were carved on the CNC machine.
Yeah.
We didn't see these being made, but again, it's all to the same tolerances as we did when we were making everything by hand, or sanding it on the belt sander. And I would say, yeah, the continuity is great. So yeah, let's put this back. Again, they locate on these 2 points. So it's exactly the same jig that we used to do the back strip. And all we do, let's get that out of the way. And it's the same cutter as well. So
yeah, no tool changing.
Yeah, tool changing is a big part of this job. So now we don't have to do that. So let's turn the vacuum on. Happy?
Yep.
Let's go.
Let's go.
Okay. Okay, so you just saw that sequence where the router was just doing these ends and cutting the ends of the braces. So if we have a look, usually the extractor's on, but we didn't put the extractor on for this video because you could see the cutter better. So it's come right in and it's cut those ends. There's a little bit of work to do with the chisel, and then some sanding, little final bit of sanding, and then that back is ready to go. The repeatability of that is so cool. So yeah, these are sort of sacrificial bits that just get broken off, and yeah, a back is done. Have you got the other back?
Sure.
Yeah.
So go upstairs, have a sort of sand in and sort of tidying it all up, and then this is where you end up.
Yeah.
With
So
it, really. But it's all cut to the length specific, in this case, to a J43.
So for this, how many of the backs have you done? You've done the Dreadnought.
Normally marks up. Oh, I don't know. So this is number 6. This one that we've just cut.
Okay.
This is the 6th one
in the process
that we've done. Yeah. So we're still sort of
just
finding little.
gradually rolling it out. You're working on a Dreadnought one.
Yeah. No. Dreadnought L20, L36, LG so far. Yeah. So I'm just working my way through now and just
all rolling out.
Them all.
And once that's done, we're moving on to the tops. Now, tops arguably are a slightly more important part of keeping an eye on what's going on with thicknesses and the way a top is carved and the way the braces are carved. So we'll go in and we'll carve them into that sort of point where it's the most you want to leave on the braces, and then we'll go in and fine tweak it at the end. So it gets this lovely kind of repeatable machining sequence, but then we can go in and do this fine detailing at the end. So the whole goal of this project, the way it started was that when we saw the 3D printer, we realised that we can probably make moulds out of a 3D printer, and things that you can do. You can put a 5-axis sort of design into it, so you can do all this sort of housing in here for all these clamps. You can drop location points in. Also, this all tapers really nicely. So eventually, these moulds are going to go onto the...
Yeah, I was going to say, these location holes here marry up with these holes here, so everything will be located, you know, the center points will just be inherent in the process.
Yeah, so at some point, if we remove those,
sure,
this will end up being on here, and it will come, the router will put the perfect radius onto the top and the back, and then we'll be able to glue the top and back on and know that they're perfect every time. All the alignment is right, the center line is perfect.
Yeah, I mean, you know, the whole point about having these little slots where the little red clips go for location is that they need to be in the same place every time, so that we can make a little notch out of the linings, and we know that it's going to marry up. That's but you have to start here and then sort of work your way backwards.
And it's a mammoth project. So that this is just one guitar. So if we've got, I can't remember, maybe 14 or 15 different models, you can see that this could stretch over a few years. But we've always been really hot on trying to do our R&D and sort of bring new ideas into our guitar making. It makes it really interesting. It uses some cool new technology that is more available than it's ever been at the price point. Anyway, so that's kind of it. I think we'll probably make another video once the tops are up and running. And I can guarantee you that this will have changed by then as well, because everything changes. You'll do a design, won't you? And then it's like, oh crikey, I could have done that.
Yeah.
So all these little tweaks go into the next version. It's prototyping in sort of real time, and we can prototype ourselves. We don't have to employ any other company to do it. So it's all in-house. It's all Atkin design, designed to make these guitars as perfect as we can make them. So look, if you've enjoyed the video, please like and subscribe. You can watch us on YouTube. We're on Instagram, TikTok, Facebook. Tell all your friends about us. But yeah, the like and subscribe is important because it enables us to make more videos like this. And we look forward to seeing you again. Take care.